So we were saying that another possibility to find MA is to do sum of moment about B. Okay, so we will write the equation here. If we do sum of moment about B equals to 0, and you will choose the counterclockwise as positive, who will give me the equation?
MA plus MB minus 2000 times 2
MA plus MB
plus MB minus 2000 times 2
minus 2000 times 2. And that's it.
minus RA times 3.
Okay, very good. Minus RA y times 3. Okay, because both RAY and the 2000 force are exerting a moment in the clockwise direction about B. So you have here, you should account for the moment of RAY and for the moment of the 2000 Newton force, and both are rotating like this. Okay, so at the end, when writing this equation, you can get by another method, you can get the value of MA, and of course it will be the same. Okay, so always remember that when you do sum of moment, you include all couples and you include all moment of forces about the point. Any question on this problem? Okay, so let us continue. Another example, we have here bar AB weighs 250 pounds and all surfaces are smooth. Find the tension and forces at A and C. First, why they said the surfaces are smooth? What can I benefit from this information? When they say smooth surface, no friction, no friction. So the force will be perpendicular to contact. So first, if I want to draw the free body diagram, at A, what is my contact line at A? At A, this is my contact line. So how will be my force at A? My force at A will be perpendicular to contact upward like this. Here I have a cable, and the cable is always in tension, okay? So if the bar is acting on it towards the left, the cable will act on the bar towards the right to be in tension. So this is the cable force. I still have a support at C, okay? Now, since it's a smooth surface, we said that we don't have friction, we only have force perpendicular to contact. What is the contact line here now? What is the contact line? This is a point, so the contact line will be along the direction of AB. This is the contact line. So how will be my force at C? It will be perpendicular to the contact line. It will be like this. Okay, so here I have three unknowns. The three unknowns are reaction at A. This is my first unknown. I have the tension in the cable T, and I have the reaction at C or C. Okay, these are my three unknowns. In order to find them, I need three equations. Okay, now I will try to use the easiest equation for me. So first, sometimes you cannot always find one force by one equation. You will have a system, okay? So sometimes you write a system of equations where all your forces are involved in the equations, and then you can solve in using the calculators your system. So for example here, let us try if we can find one of the forces by one equation directly. So if we try to think about it, if we do sum of moment about A, we have two unknowns, T and RC, okay? And if we do sum of moment about C, we have also two unknowns, RA and T. So here, There is no possibility by a moment equation to have only one unknown. Okay? Now, if we move to fx, sum of x and sum of y, if you do sum of x equals 0, you will have two unknowns, the tension in the cable and the projection of RC along x. And in y, you have as unknown RA and the projection of RC along y. So whatever you do, you will have two unknowns in your equation. This is why you can choose any three equations you want. Now, don't forget to put what? When you draw the free body diagram, these are the reaction forces, but you still have another force acting on your rod. What is the other force acting on your bar?
The weight.
The
Weight.
weight. Very good, the weight. And the weight is passing by the center of gravity. So this is W, but W is given, it's not unknown. It's equal to 250. Okay, now I will start to write my three equations. My first equation, let's say sum of forces along x equals to 0. To be able to do sum of x, I need to project RC into two components. One along, this is RC here. I should project it into y and x. How to project it? I should know the angle of this force. In order to calculate the angle of this force, let us look at the geometry of the figure. Okay? If I look at the figure, what do I have? I know that RC is perpendicular to this line, to AB. Okay? So RC is perpendicular to AB. Okay? This is why here I have an angle. So my angle here is 90. Okay? And if you look here, if I draw this line, the horizontal, if you draw the horizontal, you have the angle here is given to be 50 degrees. If this is 50, this is also 50 from geometry. Okay? So these two angles are 50 degrees. And for this one, the angle will be 90 minus 50, it's equal to 40. So we can say that the angle between RC and the horizontal is 90 minus 50 equals to 40 degrees. Once I know the angle, I can do the projection. I can find RCX and RCY. Okay? So as you can see, the projection of RC along X is negative. This is why when I do sum of forces along X, I will do plus, so I will write it here, sum of X equals 0 will give me plus tension in the cable T minus RC cosine 40. This is my first equation, and it involves two unknowns. So this is equation number 1. Now I move to the second equation. The second equation is sum of Fy equals to 0. What do I have along y direction? If you look at your figure, you have the reaction at A is in the positive direction, so it's Ra, minus the weight, which is downward, minus 250, and you also have the y component of Rc, which is upward, so plus Rc sine 40, sine 40. This is equation number 2. I still need a third equation to close my system, okay? So you can choose whatever point you want. You can choose sum of moment about A, you can choose sum of moment about C, but the easiest point will be C. You know why? Because here you have RCX and RCY, and you will get rid of them when you choose C, okay? So if I do sum of moment about C equals to 0, what do I get? Who is producing a moment about point C? I have the weight, and I have the tension, and I have the reaction. Okay, let me clear the figures so you can see them in a better way. If you look at the figure here, down, okay, if you do sum of moment about C, what do you have? So if I do sum of moments about C equals to 0, what do I have? I have first the moment of the cable force, okay? For the moment of the cable force, what distance should I take? I should take the perpendicular from C to the line of action of the force. I should multiply by this distance, okay? This distance is equal to 6 sine 50, because the angle here is 50 degrees. So the distance of F to point C is 6 times sine 50, okay? And I will choose a positive direction if I consider the counterclockwise as positive. So let us put it here. If we consider the counterclockwise as positive, so I will write first that the moment of the tension is plus T, so plus T times 6 sine 50. Okay. Now, for the weight force, I have for the weight two components, one along x, one along, for the weight, the distance, I can find it like this. I should find the following distance from here to here, okay? Because this is the perpendicular.
Doctor, isn't it 6 cosine 50 مش sine?
No, look. You mean for tension in the cable? Look, this is point C, and this is your force, this is your tension force along this direction, okay? What is the distance you want? This one. 50 is the angle here, this is 50. So you want to find this distance, which is opposing the angle 50. So what will be the formula? It's 6 sine 50, not cosine. If you do 6 cosine 50, what do you get? You get this distance here, this one, okay? Now, for the weight, to find the weight moment, okay? If I do the figure here, this is the line of action of the weight, it's the vertical. So if I do the perpendicular from C to the weight, this will be my distance here, this distance, okay? To know what is this distance, the weight is passing by the centroid, center of gravity of the bar, okay? So this distance here is equal to what? You know that because it's at the middle, the center of gravity, the distance from the total length of your bar is how much? Look, you have 4 plus 6 plus 2, 12. So your center of gravity is at 6 feet from point B, and it's at 2 feet from point C. So this distance from the weight to C is 2 feet. This distance here is 2 feet, okay? And now, if you want to find the projected distance is this one. So now, Ari, for this distance, you should do 2 cosine 50, because this angle here is 50 degrees. So the distance between the weight and C is 2 cosine 50, okay? And the moment is in which direction? The moment is in the counterclockwise direction, so it's also positive. So you should add, so you already have RC times 6 sine 60. And now you will add plus here's the tension T, okay? Plus the weight, for the weight it's plus W times 2 times cosine 50, I mean, okay, cosine 50. And what do you still have only? We still have only the moment of RA. And as you can see in the figure, RA is doing a moment in the clockwise direction about point C. And which is the distance to multiply with? To know the distance I should multiply with, this is the line of action of RA. I should take the perpendicular from C. Okay, so this will be my distance. To find this distance, you have that from A to C, you have 2 plus 6, 8. Okay, and to find this distance here, you need the angle. This angle here is 50. Okay, so what will be the distance here? It will be 8 cosine 50. Okay, so for RA, it's minus RA times 8 cosine 50. Okay, and now this is equal to 0. You have 3 equations, 3 unknowns. You can solve for your system. Okay, and also here you can try to do sum of moment about A. It will also give you a third equation. So you can do sum of moment about any point you want. Any question? Okay, thank you. So we will continue next time.
Thank you, Doctor. See you next time.
Bye bye.